Thank you very much. I have to say that today, if I were sitting in your shoes or when I was your age or so, I was thinking back to when I was about 15, what would I think I would be doing when I'm not going to say my age, but a while later. And I think I would be pretty surprised at what I'll tell you tonight. One, I'm surprised by the opportunities I've had and the work I've gotten to do. And two, I'm surprised by the advice I'll give you at the end. So I'll start with my background, though. I grew up in Union County. I live there now. I grew up near Norris Lake, if you're familiar with that area. Attended schools in Union County. Had some great opportunities in high school. Union County is often thought of as I think your all's term is underrepresented or rural school, but I was very fortunate to have some amazing opportunities. I was very active in 4-H, which gave me exposure to public speaking, leadership, citizenship, growing things, making biscuits, all that kind of stuff. And I also had some really fabulous teachers along the way. I really was intrigued by biology, so I imagined that I might do something in biology. I asked my mom one day, do you think I'd be a good doctor? And she said, no. She said, you have a terrible bedside manner. So if somebody came to you complaining, you'd give them some aspirin and tell them to go on. And she was probably right about that. It turns out, for you adults out there, it turns out I really don't like dealing with insurance either, so I think I'd be a terrible doctor now. But I was still interested in biology and trying to figure out what I was going to do with that. I also really liked solving puzzles. I like jigsaw puzzles, I like all kinds of puzzles, and just putting pieces together and solving puzzles. So I imagined a career, maybe in research, doing something in biology, and then going home and working the crossword or something. But then my algebra teacher suggested that I think about engineering. And I'd had some friends older than me that had tried engineering and it was really hard. And they changed majors, so I thought, there's no way a kid from Union County can go to a big university. And there's just no way. But she kept encouraging me, and I thought, yeah, if they're crazy enough to let me in and let me try it, I'll try it, and then I can switch. So I ended up majoring in agricultural engineering. Which is a great combination of my interest in biology, my rural background, and my experience on a farm, and then engineering. I also had an opportunity in high school to come to ORNL for 2 weeks. So I was in a program sponsored by the Appalachian Regional Commission, which is also managed by ORL. And I spent 2 weeks between my junior and senior year doing research with a researcher in the material science group. So we were testing ceramics and how fracture mechanics work in ceramics. What's really interesting is I've since gotten to chat with that researcher who's still at the lab, and we talk every now and then, which is pretty cool. So through all that, I decided to major in agricultural engineering. I went on to UT terrified because I didn't have the advanced courses that many of my neighbors had. I didn't have any advanced placement. We didn't have any of that. So I was really terrified. And I remember making a 93 on my very first calculus test and thinking, okay, maybe there's a shot here. So I stayed the course and have been in engineering since. While at UT, I got to work on some fabulous projects there too. I worked for professors several different times, and we worked on constructed wetlands for waste treatment. And that project was pretty cool because we got waste from the M&M Mars factory down in Cleveland. We got the microbes from the Budweiser plant north of Atlanta, and we created anaerobic digesters to treat those wastes and study that, which was pretty neat. We also did a constructed wetland for dairy waste. So there used to be a farm across the river from the ag campus at UT. We'd go over there, get buckets of manure, come back every week and treat those wetlands, and we studied how the plants would treat the water. From there, I went to the University of Kentucky. So I joke that I stay in the SEC along I-75. Or I started with orange, and I added some blue. And then, so I went to the University of Kentucky, and I studied plants in greenhouses. I really liked controlled environment. What I really like is how the biology and the physical environment interact. So the way my project there was on poinsettias. If you cut a poinsettia, the end of it, to make a new poinsettia like you see in the store, they're not seeds or anything. They take a larger one, cut the little clipping in the summertime, put it in some foam media, and let that grow for the Christmas season. The challenge was those new little cuttings don't have roots. So how do they get water? Well, they have to mist them a lot. So they keep misting and misting and misting. But they do develop roots. So at what point do they develop enough roots so you can trim the water back, so you can conserve the water that you're applying? And so I did 2 pieces there. I built this crazy contraption to apply heat to the bottom in a controlled way. It was a little heat table that had cold water on one side, hot water on the other. So I had a gradient, and I could apply different temperature treatments. And we studied how the root temperature affected root development. So we would cut those cuttings, we would take a little slice of the bottom of those cuttings and study them under a microscope to see those roots. And then I tried to correlate that with how much water they needed. So that was a pretty neat project. Then from there, I told you I had orange, then I had blue, and then I went back down 75 to Florida, and I had orange and blue. And there I had an opportunity to work on a project. I'd had an NSF fellowship starting at Kentucky that went with me to Florida. I also got a NASA fellowship, and I worked on a greenhouse for Mars. The question there, I think this is the one most people are interested in. So the question there is, if you have explorers going to Mars, what will they eat? Well, plants are helpful. Actually, my mama taught me earlier that if you can, she always told me growing up that if you can grow a potato and cook it, then you'd be fine. Well, Martian, the movie Martian proved that to be true, and she's right. She taught me how to grow potatoes and then cook. But there we were actually using radishes. So we'd take these little radish plants, and I used a bell jar. I had 3 treatments. I designed the base, and then the shop at the Kennedy Space Center built this little base, which is an interesting process because mine was not a priority project. They were also building components for the shuttle, so my project took a little longer, but that's okay because it was a great shop. And so we could control the temperature, the humidity, the carbon dioxide level, and those kind of things in that radish environment. And then we had a vacuum applied to it. So we were trying to see how they would react in a lower pressure environment. The concept there was if you send explorers to Mars and they're going to need food, so you have a greenhouse, you need to grow food, but the atmospheric pressure on Mars is very low. And if you try to build a greenhouse that would simulate an Earth environment inside that greenhouse, it's going to be a massive structure, which is very expensive. That comes into payload, and payload is everything when you're planning any kind of space mission. So and the payload to be able to lift that off for that rocket would be prohibitive. So instead, we talked about an inflatable greenhouse. The greenhouse would go before the explorers. Robotically, it would inflate. Plants would be started, and then you'd have plants growing when they got there. Now, the astronauts would still need full gear in that greenhouse, but they could go from their astronaut habitat to the greenhouse and get plants. So what I found is that if you have radish plants and you put them, I did different pressure treatments. At the lowest pressure treatment, they wilted so very fast. We'd apply that pressure, and because of it's very simple. There's a lot of water molecules inside the leaf, very few outside, and they all left. Well, but I found out if you increase the carbon dioxide, stomates close, and the plants could handle it better. So that was the kind of work I was doing. I was always also looking at leaf temperature. It's very cold on Mars, so the radiative heat transfer would reduce the temperature of those leaves quite a lot. So that was my work there. From there, I went to the University of Kentucky a little while, doing some agricultural extension work, and then always wanted to come back home. So when an opportunity at ORNL presented itself, I jumped at it and got to come back home. So, and at ORNL for the past 10 years or so, I've worked on bioenergy, and particularly feedstocks for bioenergy. So how can I don't really work on the growing part, but how can I harvest, transport, process stalks, leaves from corn or wood or grasses to make those suitable feedstocks for conversion to cellulosic ethanol. So we study how to get the plant matter to there in a commercial setting. So how do you transport that? How do you store it? And then other researchers will figure out how to break that biomass down and get into the sugars, and then be able to use that to make fuel or other chemicals or whatever. Now, we've also started in the past few months using those same kind of supply chains and thinking about those same kind of biomass supply chains and getting ground up biomass that we can print with. So we've been doing 3D printing with plants, and that's pretty exciting. In fact, tomorrow there's a display at the Earth Day Texas, I think, which is the largest Earth Day symposium in the country, and the Secretary of Energy will be there, and we're pretty excited. He'll get to see some of our work, some of the things we printed with biomass there. Another project I have, we heard about fire earlier in the safety video, but one of the nice things about biomass is that it burns well. It has a lot of energy, so you can burn it and get thermal energy out of it. A bad thing about biomass is that it burns well. So if you've ever seen a hay fire, they're pretty impressive. So we've gotten to do some work at Underwriters Laboratory in Chicago to study how these bales of corn, stover, and switchgrass burn, and how we can design systems to reduce that risk. So, for example, we've gotten the data that we needed for fire codes to be able to design sprinklers if you have biomass in a facility. That way, if you have a fire, you know when you're designing the building that would house that, what size sprinklers you would need. And then next, we're going to be doing some studies this summer on big stacks of bales, how they burn, and how far apart those stacks should be, and how we can, and the smoke generation. So what's happened is when there's fires, the smoke impacts the surrounding community. So maybe we can design those facilities to reduce those impacts. So that's a really quick overview of the kind of things I've done along my career, all the way from Tennessee and all the way back to Tennessee. I thought I'd tell you a little bit about what I think are, I hate to say secrets, they're not secrets, or tips, I suppose, of what I would do, what I did well and what I would do differently. One of the things that I was telling you, I was surprised by what I might say, and I thought when I was your age, it was all about math and science. And it is a lot about math and science. But I think in my career and along my educational path, a big key to that I failed to factor in were the people that I interacted with along the way. In fact, part of the reason I chose engineering, I told you I would have a terrible bedside manner. I didn't really want to work with people. I thought that I could pick engineering and be all about machines or, like biology, cells, whatever, and I really wouldn't have to work with people. That is completely wrong. Very naive and completely wrong. And so now, along the way, the mentors that I had were very important. The teammates that I had were very important. And I think that now in my career at this stage, they're even more incredibly important. The people that I meet, it's important to treat them respectfully. It's important to be a good teammate and all those things. And then, so my advice there is to be kind. I think that it's easy in STEM fields and everything to feel like it's all about competition, which sometimes can breed arrogance and competitiveness. And competition is important, but being kind to people, being a good teammate is also critically important. In fact, I read a story the other day. It was an essay by an admissions officer, I think at Dartmouth. Maybe some of you saw it, but she said that the college applications she gets now, especially at a school like Dartmouth, are all amazing. These students are all incredible. It's really hard to distinguish one good one from another. But one that really stood out to her is an application that had a reference letter from a janitor at the school. And this janitor talked about how respectful the student was, how helpful, and how responsible, and that really was key into his acceptance into Dartmouth. That was important to them. And I find that to be very true as well. The other thing I would tell you is we know that hard work is important. I think going along with that is I tell people just to show up every day because it's really easy. And girls, I'll talk to you for a minute. I think girls especially, I've found, and research backs this up, if you have a hard math class, if you have a difficult test, if you don't do well on a test, girls tend to think that they're just not cut out for that. That math, science are abilities that you either have or you don't. Boys tend to think, and again, research backs this up, boys tend to think if they have a bad exam on a test, I'll just work harder next time. I'll just show up, I'll just work a little harder and then it'll be fine. And on this, no, I'm just kidding, not only this, but the boys are right, I think, on this one. Because if you have a difficult time and something doesn't go very well, my advice is just shake it off. Don't let that get you down. It's not a reflection on you as a person. It is just on that particular day, that particular experience. Show up the next day, keep working, and keep going, and it works out. So I think I always try to tell girls that hard work it's not about ability, it's not innate, and STEM really does require hard work, and it is possible to learn more and to work to the next level. I had one more piece of advice. Those are the two key ones. Oh, the other one I was thinking of, I've heard a lot of folks talk, parents and guidance counselors talk lately about students that they have to help a lot now with high school students to prepare college applications and to meet deadlines. And that's troubling to me because I think if parents and teachers are guiding that process and driving that process, I predict the chance of success for that student to be pretty low. And I say that because when I look back at all of my experiences, the one thing they all had in common is I had to either do a proposal or an application, and I had to meet a deadline. And so none of my opportunities would have been possible had I not completed an application in a quality way and met a deadline. And that seems like very basic advice, but I think it's really critically important. And when you start into college, if you can't meet deadlines, then it won't go very well. Your professors won't be happy, it won't go very well. Very basic advice. So at that, I think they're giving me time, so I'll wrap up and entertain questions.